When my daughter was 10, she's now 25, I wrote an open letter to her about how to think critically and scientifically. And it was my plan to read this open letter just means that it was published at the same time. My plan was to read this open letter, but in the car coming here, I was told that I was billed to talk about evolution. So what I thought I would do was to shorten my reading from the open letter and then ad-lib a bit about evolution. I haven't prepared to talk about evolution at all, but I think I kind of might manage to say something. So I'm going to begin by some brief extracts from the open letter to my daughter, Juliet. Dear Juliet, now that you're 10, I want to write to you about something that is important to me. Have you ever wondered how we know the things that we know? How do we know, for instance, that the stars, which look like tiny pinpricks in the sky, are really huge balls of fire, like the sun, and very far away? And how do we know that the Earth is a smaller ball whirling round one of those stars, the sun? The answer to these questions is evidence. Sometimes evidence means actually seeing, or hearing, feeling, smelling, that something is true. Astronauts have travelled far enough from the Earth to see with their own eyes that it is round. Sometimes our eyes need help. The evening star looks like a bright twinkle in the sky, but with a telescope you can see that it is a beautiful ball, the planet we call Venus. Something that you learn by direct seeing, or hearing, or feeling is called an observation. Often, evidence isn't just observation on its own, but observation always lies at the back of it. If there's been a murder, often nobody except the murderer and the dead person actually observed it. But detectives can gather together lots of other observations which may all point towards a particular suspect. If a person's fingerprints match those found on a dagger, this is evidence that he touched it. It doesn't prove he did the murder, but it can help when it's joined up with lots of other evidence. Sometimes a detective can think about a whole lot of observations and suddenly realize that they all fall into place and make sense if so-and-so did the murder. As an aside, in my new book, The Greatest Show on Earth, I use the same metaphor of a detective coming upon the scene of a crime after it's happened, unable to actually witness the crime, but able to piece together from surviving evidence how it must have happened. That's what we do as scientists in getting evidence for evolution. We normally can't see evolution happening because it happens too slowly, it happened too long ago, but like detectives, we can piece together the evidence and it's utterly overwhelming. Back to the open letter to Juliet. Scientists, specialists in discovering what's true about the world and the universe, often work like detectives. They make a guess, called a hypothesis, about what might be true. They then say to themselves, if that were really true, we ought to see so-and-so. This is called a prediction. For example, if the world is really round, we can predict that a traveller going on and on in the same direction should eventually find himself back where he started. When a doctor says that you have measles, he doesn't take one look and see measles. His first look gives him a hypothesis that you may have measles. Then he says to himself, if she really has measles, I ought to see ... Then he runs through his list of predictions and tests them with his eyes. Have you got spots? His hands. Is your forehead hot? And his ears. Does your chest wheeze in a measly way? Only then does he make his decision and say, I diagnose that the child has measles. Sometimes doctors need to do other tests like blood tests or x-rays, which help their eyes, hands and ears to make observation. The way scientists use evidence to learn about the world is much cleverer and more complicated than I can say in a short letter. But now I want to move on from evidence, which is a good reason for believing something, and warn you against 3 bad reasons for believing anything. They are called tradition, authority, and revelation. First, tradition. A few months ago, I went on television to have a discussion with about 50 children. These children were invited because they'd been brought up in lots of different religions. Some had been brought up as Christians, others as Jews, Muslims, Hindus, or Sikhs. The man with the microphone went from child to child, asking them what what they believed. What they said shows up exactly what I mean by tradition. Their beliefs turned out to have no connection with evidence. They just trotted out the beliefs of their parents and their grandparents, which in turn were not based upon evidence either. They said things like, we Hindus believe so-and-so, we Muslims believe such and such, we Christians believe something else. Of course, since they all believed different things, they couldn't all be right. The man with the microphone seemed to think this quite proper, and he didn't even try to get them to argue out their differences with each other. But that's not the point I want to make. I simply want to ask where their beliefs came from. They came from tradition. Tradition means beliefs handed down from grandparent to parent to child and so on, or from books handed down through centuries. Traditional beliefs often start from almost nothing. Perhaps somebody just makes them up originally, like the stories about Thor and Zeus and Apollo. But after they've been handed down over some centuries, the mere fact that they are so old makes them seem special. People believe things simply because people have believed the same thing over centuries. That's tradition. The trouble with tradition is that no matter how long ago a story was made up, it is still exactly as true or untrue as the original story was. If you make up a story that isn't true, handing it down over any number of centuries doesn't make it any truer. Now I want to turn to the other two bad reasons for believing in anything: authority and revelation.